Hey, what's up, Ziguanas? This is day 24 of the 30 days of the coding challenge. Join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new programming language. The name of the language is Zig. My name is Dusan. Welcome to Zignited. Yeah, 24, day 24 already. So 6 days more after today, and that's about it for the 30 days of the coding challenge. But like I mentioned before, I will continue working afterwards. I will stream. I still don't know how I will stream and which topics I will cover. Maybe I will do Zig links for the stream part. I will also do a lot of off-stream deep research on Zig, and I will also create a tutorial for Zig. That's the plan. Hi, Robert. How are you? Good evening. Yeah, let me actually ask you something, Robert. If you're willing, today we can go through your code after this regular stream. So if you have time, so we can make a special stream and go through your code that you posted on GitHub. Just let me know if you're willing and we can do it. And let me jump right into the documentation. So for today, memory and also source encoding. That's the plan. Robert says, sure, if we want. Okay, perfect. If I want, yeah, let's do it then. So I will then try not to make this one a long video so that we can do your code review and see. I mean, not review the code, but let's see how you improve tic-tac-toe and which Zig elements you use to show us how to practice Zig even more. No problem for yesterday. Yeah, no problem. Okay, let's jump into memory then. Let's see what they say. And by the way, these few last days were a bit more theoretical because the topics are like that. So there is not that many code, and it's more important to understand the theoretical part. So that's simply how it is, because we covered most of the things that are easy to practice before. So let's see about the memory. The Zig language performs no memory management on behalf of the programmer, so no garbage collection. This is why Zig has no runtime and why Zig code works seamlessly in so many environments, including real-time software, operating system kernels, embedded devices, and low latency servers. This is something that you do, right, Robert? I think you mentioned you're doing some low latency servers or something about performance servers. I forgot. Not in Zig, if I remember correctly. You said something like C++. Correct me if I'm wrong. As a consequence, Zig programmers must always be able to answer the question, where are the bytes? Yeah, so we have to take care of them. No garbage collector. Like Zig, the C programming language has manual memory management. However, unlike Zig, C has a default allocator, malloc, realloc, and free. When linking against libc, Zig exposes this allocator with stdhibc allocator. Okay. However, by convention, there is no default allocator in Zig. Instead, functions which need to allocate accept an allocator parameter. Likewise, data structures such as stdarrayList accept an allocator parameter in their initialization functions. And they provide here the example. Robert says kinda. About his work, it's combination of a lot of C, a lot less C++, and even some C#. Interesting. A lot of C's. And yes, it's high perf servers. Yeah. Thanks for explaining. Let's see what they do here. So they create one constant allocator from the standard package, right? Standard library. mem allocator. Then they create another one, call it expect, and they, okay, this is for testing only. So then let's see what they do in the main code. So they create a buffer variable, which is an array of U8s with 100 elements, so size 100, and they set it to undefined. Then they create another variable, FBA, which they assign to what they get from this buffer, from the address of the buffer, when they call this init method deep down here in std library, in heap, in fixed buffer allocator. So that's FBA fixed buffer allocator. Okay, const allocator is the next thing they do. So they instantiate, I guess this is like a constructor function or something similar that they use from this fixed buffer allocator to get the allocator. Then they create another constant result. They, okay, let's see what they do. They concatenate foo and bar, and they use this allocator to concatenate, and then they try to see if foo bar string literal is equal to the result, and the result is this concatenated, so it should be the same, right? Yeah, one test passed. Okay, and they were comparing them as U8s, as U8 type. Let me see what Robert said. Zig is manually managed. Yeah, no garbage collection. Then there is, Robert says, there is a vtable interface, std mem allocator, that you pass around in Zig. Okay. Thanks for explaining. So this is an interface then. The allocator is an interface. Okay. Let's see what they do in this function. How they actually, under the hood, concatenate these two strings using the allocator. So they pass the allocator, right? That's the first parameter here, the first argument they pass. Then they say, of course, it's a type of allocator. So the one here, which is std mem allocator. So this is this interface that Robert is mentioning. And let me see what you wrote, Robert. The FBA allocator returns this interface. Thank you. Then they have A and B, which are, we see that here they're using string literals, but again, because there is no string type in Zig, this is under the hood a slice. So it's going to be, this is under the hood as array, but they are here using the parameter instead of arrays, they're using a constant slice of U8s. So they are going to coerce an array into slice both times for A and B. And then what they do here as what they return, the return type of the function is union of U8 slice, if I'm not mistaken. And then what they do inside, they create one constant result. So it's not the same like this one here. They're in the different scope. They're not related. Then they use this allocator, write this interface. Then they call the alloc method on it, and they take the length of the first slice here, which is in this case coming from this string, and the length of the second one. So they are summarizing the length, and they are going to allocate that many bytes, right? Bytes because they say the type is U8. So I guess if they were to say U16s, then it would be this length, the summary of length, times 2 bytes inside of the memory. Let me see what Robert says. You always get return memory from to this interface. But this interface can have different allocation strategies behind it. So yeah, it's literally an interface. So you don't get not you don't get, you don't have to care about how it does the job, but you know that you can use it, okay? I mean, of course, it will be helpful if you know what happens under hood, but let's see the next thing. They use, I remember this built-in memcopy. They say they want to copy what? They want to copy A into the result from the first position up to the length of len. And in a similar way, they want to copy B, but from the point where the A stops, which makes sense because they want to concatenate them to put them next one after the other. And because this is not inclusive, and this is inclusive, so the starting point is always inclusive and the end point is not, which means they're not going to overlap. So where this one ends, I mean this entire slice ends, then this one will begin and it will go until the end of the slice. So because it's allocated in a specific size, it's going to go, in this case, 6 bytes, right? Because we have 6 characters. And like I mentioned before, it's not always 1 byte per character, depending on the character. So in Unicode, these ASCII characters at the beginning, they are 1 byte, but later, so for example, some Chinese character emojis and so on, they will be multiple bytes per character. So they might appear as a single character, but under the hood, they could be 2 or 3 bytes instead of 1. And then they return the result. Yep. So that's why they pass this test here. Let's see what Robert says. Here it is fixed buffer allocator. So this is the specific case, how they use this interface here. So they are using the fixed buffer allocator, which literally takes a buffer of bytes and uses it when you allocate free. In this example, you give it a buffer of 100 bytes that sit on a stack. So you are literally allocating on stack. If you allocate more than 100 bytes, it returns an error. Yeah, so this is the max capacity of the buffer. And we are, in this case, allocating 6% of it, right? So only 6 bytes. Okay. Okay. Then let's see what else they say in the above example. 100 bytes of stack memory are used to initialize a fixed buffer allocator, which is then passed to a function. As a convenience, there is a global fixed buffer allocator available for quick tests at SAD testing allocator, which will also perform basic leak detection. Zig has a general purpose allocator available to be imported with SAD heap general purpose allocator. However, it is still recommended to follow the choosing an allocator guide. So I'll just open it up to see how it looks like and where this comes from. So it's in the same part of the docs. I'll just save it for later. It's here. Okay, I'm blind sometimes. What allocator to use depends on a number of factors. Here is a flowchart to help you decide. Okay, are you making a library? In this case, best to accept an allocator as a parameter and allow your library's users to decide what allocators to use. Allocator. Are you linking libc? In this case, SAD heap C allocator is likely the right choice, at least for your main allocator. Third use case, if you need to use the same allocator in multiple threads, multi-threading, okay. Use one of your choice wrapped around SAD heap thread safe allocator. Wrapped around this one. Okay. So I was kind of expecting that it's the other way around, that this one will wrap the one of your choice, but it's kind of the other way around. Sometimes I have something like invert logic, I don't know why, in my mind. The fourth use case is the maximum number of bytes that you will need, bounded by a number known at comp time. in this case, use std heap fixed buffer allocator. So this is the one that we use, right? Fixed buffer allocator, yeah. Then the last one, is your program a command line application which runs from start to end without any fundamental cyclical pattern, such as a video game, main loop, or a web server request handler, such that it would make sense to free everything at once at the end? In this case, it is recommended to follow this pattern. Let's see what is the pattern. They have, okay, this is just the regular main function. Then the important thing is what's inside. They have a variable called arena. They take this heap arena allocator and they initialized the page allocator. Then they defer arena init. So this is the first time I see. I kind of heard about deferring in Zig before, but this is the first time that I remember seeing it in docs. At least if I saw it before, I skipped because I was doing some more basic things. So defer arena init. Then they create a const allocator, arena allocator. Then the constant pointer. They use the allocator to create i32 pointer. Then they are printing it. So the pointer, and they dereference it right here. And let's see what they are getting. So yeah, they're just getting some memory address of a pointer. Okay. So let me just see what Robert wrote. Give it a buffer. Okay. These allocators changed quite a bit since this was written. The things are named differently in most of the cases nowadays. Okay. But just to have some idea in general. So then I will not memorize the names. Just to... So this is to free everything at once in this pattern. So they had one page allocator. And this is on the heap. Arena allocator, okay. Then arena init. Allocator, arena allocator. Okay. Okay. So then let's see what they say. When using this kind of allocator, there is no need to free anything manually. Everything gets freed at once with the call arena init. So, and they are deferring it. So it means it's going to happen at the end. So I haven't touched this in Zig, but I know in some other languages, if you do the defer, it typically does this at the end of the scope. So yeah, I kind of now remember that I mentioned this also here in live stream, but it was so a long time ago, I forgot how deep I went into it. Are the allocations part of a cyclical pattern, such a video game? Why they are repeating this? This is without cyclical. Okay, yeah. Sorry. So now this is the example where you actually have a cyclical pattern. So a video game, main loop, a web server request handler. If the allocations can all be freed at once at the end of the cycle, for example, once the video game frame has been fully rendered or the web server request has been served, then this is a great candidate. So the same like before, right? As demonstrated in the previous bullet point, this allows you to free entire arenas at once. Note also that if an upper bound of memory can be established, then std heap fixed buffer allocator can be used as further optimization. So if you know in general how much memory you are going to take, you can combine. Are you writing a test and you want to make sure error out of memory is handled correctly? In this case, use std testing failing allocator. Are you writing a test? In this case, use std testing allocator. Finally, if none of the above apply, you need a general purpose allocator. Zig's general purpose allocator is available as a function that takes a comp time struct of configuration options and returns a type. Generally, you will set up one STD heap general purpose allocator in your main function and then pass it or sub allocators around to various parts of your application. You can also consider implementing an allocator. Okay, where the bytes string literal such as hello are in the global constant data section. This is why it is an error to pass a string literal to a mutable slice like this. So let's see what they do. They have this function foo, which takes in a slice of U8s. They call it S. They don't return anything, so void. They just dump it. String literal to a mutable slice. Yeah, because it's not const, it's mutable. I remember having problems with this tic-tac-toe. So then foo hello and it breaks. However, if you make the slice constant, then it works, and they just added here a const. And this is also like a syntax. It was a bit weird to memorize. So when it's not a constant, they glue the square brackets to the type. And when it's a constant, they have this space here, and they say const after the array. Yeah, but now I'm kind of used to it already. And this one passed normally. Let me see what Robert wrote. Yes, it is end of the scope. Deja vu, yeah. Deja vu. Deja vu, deja vu. Just like string literals, const declarations, when the value is known at comp time, are stored in the global constant data section. Also, compile time variables are stored in the global constant data section. Okay. So both const declarations and comp time variables. Var declarations inside functions are stored in the function stack frame. Once a function returns any pointers to variables in the function stack, stack's frame, become invalid references, and there is a comma here, sorry. So once a function returns, once the function returns, not when I thought they are going to say that functions return something, but this is the focus when function basically finishes the life cycle. So when it returns, then any pointers to variables in the function stack frame become invalid references, and dereferencing them becomes unchecked illegal behavior. Okay. Yeah, in some languages you can have closures that actually can access something after the function returns. But here it's not the case. So let's see the next one. Var declarations at the top level or in struct declarations are stored in the global data section. Okay, so like the comp time variables and the const. The location of memory allocated with allocator alloc or allocator create is determined by the allocator's implementation. Okay. Implementing an allocator. Zig programmers can implement their own allocators by fulfilling the allocator interface. In order to do this, one must read carefully the documentation comments in standard mem Zig and then supply a alloc function and resize function. There are many example allocators to look for inspiration. Look at standard heap Zig and standard heap general purpose allocator. Okay. Heap allocation failure. Many programming languages choose to handle the possibility of heap allocation failure by unconditionally crashing. By convention, Zig programmers do not consider this to be a satisfactory solution. Instead, error out of memory represents the heap allocation failure, and Zig libraries return this error code whenever heap allocation failure prevented an operation from completing successfully. Some have argued that because some operating systems such as Linux have memory overcommit enabled by default, it is pointless to handle heap allocation failure. There are many problems with this reasoning, and they will now make a case for it. Only some operating systems have an overcommit feature. Linux has it enabled by default, but it is configurable. Windows does not overcommit. Embedded systems do not have overcommit. Hobby operating system may or may not have overcommit. Yeah, basically it's unknown. For real-time systems, not only is there no overcommit, but typically the maximum amount of memory per application is determined ahead of time. When writing a library, one of the main goals is code reuse. By making code handle allocation failure correctly, a library becomes eligible to be reused in more contexts. Although some software has grown to depend on overcommit being enabled, its existence is the source of countless user experience disasters. When a system with overcommit enabled, such as Linux on default settings, comes close to memory exhaustion, the system locks up and becomes unusable. At this point, the OM killer selects an application to kill based on heuristics. This non-deterministic decision often results in an important process being killed and often fails to return the system back to working order. Let me see what you guys wrote before I continue with recursion. Classic to-do moment. Hi there, hi Dev, how are you? Yeah, today I started earlier because I was home. Let's see what they say. Oh, last time I read about this was when I was learning Rust. Recursion is a fundamental tool in modeling software. However, it has an often overlooked problem: unbounded memory allocation. Recursion is an area of active experimentation in Zig, and so the documentation here is not final. You can read summary of recursion status in the 030 release notes. The short summary is that currently recursion works normally as you would expect, although Zig code is not yet protected from Stack Overflow. It is planned that a future version of Zig will provide such protection, with some degree of cooperation from Zig code required. Okay. Yeah, by the way, you probably guys know, but I did play a bit here on the channel with recursion when the channel reached 100 subscribers. So I did print recursively 100 times. Thanks. Okay, lifetime and ownership. It is the Zig programmer's responsibility. And I was just like improvising because I haven't read this documentation. I just like wanted to try. I know how it works in different programming languages, so, and it was pretty much the same. Lifetime and ownership. It is the Zig programmer's responsibility to ensure that the pointer is not accessed when the memory pointed to it is no longer available. Note that a slice is a form of pointer, in that it references other memory. In order to prevent bugs, there are some helpful conventions to follow when dealing with pointers. In general, when a function returns a pointer, the documentation for the function should explain who owns the pointer. This concept helps the programmer decide when it is appropriate, if ever, to free the pointer. For example, the function's documentation may say caller owns the return memory, in which case the code that calls the function must have a plan for when to free the memory, that memory. Probably in this situation, the function will accept an allocator parameter. Sometimes the lifetime of a pointer may be more complicated. For example, the std_arrays list, generic type dot items, slice has lifetime that remains valid until the next time the list is resized. So the array lists, okay. Such as by appending new elements. Okay. I know that usually when they resize, they double the size most of the times when they resize in other languages. So probably here the same. The API documentation for functions and data structures should take great care to explain the ownership and lifetime semantics of pointers. Okay. Yeah, so this is, then it's up to developers, right? Ownership determines whose responsibility is to free the memory referenced by the pointer, and lifetime determines the point at which the memory becomes inaccessible, lest illegal behavior occur. Least, sorry, not lest. Yeah, I didn't go through this section, so I will definitely, this is what I already did. So let me see, somewhere near the end, there was this other topic that I wanted to cover today, source encoding. Let me just double check. Yeah, source encoding was the next thing I wanted to do today. Let me see what you guys wrote. Can you explain the first line of recursion, please? You mean in the code that I did for 100 subscribers? 100 subscribers, that one? In the docs. In the docs. Let me see where the recursion was. I didn't see any code here. See in the release notes. No. Unbound memory access. Give me just a second. Unbound memory access. Where was that? Let me see what Robert says. The problem with recursion is that it can overflow the stack, which is meant by this. That you... the first line... sorry, I entered the first line of the code. I was looking for the code. You meant literally like the explanation, the first line of explanation. Let's see. Unbound memory allocation. Yeah, so this is, like Robert says, it can cause a stack overflow, which basically means every time you call a function, it needs a memory to run. So you usually have some variables. Even if you don't, you need some basic memory to allocate for it to work correctly. But it will take usually also some space to declare variables and so on. And then if it calls itself, it will populate the stack quickly. So if you call it, if it calls itself like 1000 times, it will already like take 1000 times the space that one call needs. And if you keep doing this uncontrollably, you will eventually run out of memory, and you can do it very quickly like this. And this was used before, I don't know, let's say 30, 40 years ago, when hackers were doing this in C and similar languages to access the memory that they shouldn't have. So imagine that you have some password, hidden, whatever, hidden data that you shouldn't have access to, that could give you control of the operating system of someone. So you are bound by memory that you cannot allocate, you cannot touch any memory outside of some range. But if you do this recursive calls, you will, in those days, you would uncontrollably breach these boundaries of the memory, and you will eventually reach. So they calculated, literally, like when they hacked, they calculated how many times they have to call the functions to reach into a specific memory that was out of these bounds to get some data and to maybe to inject something or just to read the data. So depending what they wanted to do. And they used to crash operating system. But modern operating systems, they have protection for this. Even the programming languages now, they have these. So in Zig, I think it's 1000 recursive calls by default. In Python, it's also by the settings, 1000 recursive calls. So the programming language will not let you do it. But even if you override all these things, then the operating system has the protection nowadays, so it's not the same like 40 years ago, but still it can just like destroy your memory. It can leak your memory. You can think about it literally like if you went into the elevator sometimes when you have two mirrors, so you know like the effect when you have like the infinite reflections. This is something like that, so it can happen very fast and you just like populate uncontrollably the memory. Let's see what you guys wrote. You don't know ahead of time how much stack memory you need. Memory, that's interesting, never thought that. Otto, hello Otto, welcome. It doesn't have rec op like tail call op. I'm not sure how Zig works. I'm just learning it. Let's see what Robert says. Most of the operating system allow you to have 1 to 8 megabytes of stack. Then they kill you. Yeah, the modern operating systems are protected, so they allow this before, but nowadays, I mean, they haven't thought about it because nobody was doing it. And then when they realized how they're getting hacked, of course they patched it. And then Robert responds to Otto, it does, but not everything can be optimized by it. In cases where you can optimize it out, it means you didn't need recursion in the first place. Yeah, thanks, Robert. Yeah, by the way, for Otto and other, and maybe Otto knows, but for people that are not aware, I'm learning Zig live. So I'm not expert at all. I'm I'm a novice in Zig. So this is my day 24 of learning Zig. So I've just learned what I've learned in these 24 days. That's what I know. And the point of this stream is just that to document my learning process of Zig. So I do have a lot of experience with other languages, but not with Zig. So I'm learning literally now. Okay, let's go to sources encoding, I believe. Let me just double check. Yeah, source encoding is the next thing on the menu. Zig source code is encoded in UTF-8. Okay. An invalid UTF-8 byte sequence results in compile error. Throughout all Zig source code, including in comments, some code points are never allowed. Let's see, that's interesting. ASCII control characters, except for, so they are like the first 32, I think, if I'm not mistaken, except for these. So this is line feed, carriage return. What was the HT? I forgot. Horizontal tab, maybe. And some others, which I don't know what they are. Then non-ASCII code, non-ASCII Unicode line endings. These. So I don't know what they stand for. EL, LS, and PS. Line feed byte. Okay. Is the line terminator in Zig source code. This byte value terminates every line of Zig source code except the last line of the file. It is recommended that non-empty source files end with an empty line, which means that the last byte would be, again, line feed. Okay, yeah, this is also true for other languages. They want you to have an empty last line. Not all, but some. Each line feed may be... So in Python, it's by the convention, let's say. So you don't have to do it. It will still work, but it's recommended, for example, that you have the last line. It will be a warning if you don't do it. Not an error. Each line feed may be immediately preceded by a single carriage return. Byte value this one, code point this one, to form a window-style line ending, but this is discouraged. Note that in multi-line strings, carriage return line feed sequences will be encoded as line feed. When compiled into a Zig program, carriage return in any other context is not allowed. Then I believe hard tabs, not horizontal tab. Okay, hard tabs. Byte value okay are interchangeable with SP spaces. Spaces are SP. That makes sense. Byte 0x. Yeah, how didn't I recognize this 20 hexadecimal deck code? It's the same in web. Code point as a token separator, but use of hard tabs is discouraged. See grammar. For compatibility with other tools, the compiler ignores UTF-8 encoded byte order mark if it is the first Unicode point in the source text. A byte order mark is not allowed anywhere else in the source. Okay, note that running Zig FMT on a source file will implement all recommendations mentioned here. Note that a tool reading Zig source code can make assumptions in the source code. Is assumed to be correct Zig code. If the source code is assumed to be correct, okay. For example, when identifying the ends of lines, a tool can use a naive search, such as this one, or advanced search, such as, so this is regex, I believe. And in either case, line endings will be correctly identified. For another example, when identifying the white space before the first token on line, a tool can either use a naive search or advanced search like this one. And in either case, white space will be correctly identified. Let me see what you guys wrote. Robert says, just saying you can artificially raise the stack limit that OS gives you. Also, it is different for main thread and subthreads you create. Yeah, that's interesting. Hello, Andre, how are you? Andre says, they are so discouraged. It's compile error to have tabs in comments. Thanks, Andre. So no tabs in comments. Let's just see the keyword reference. This is, I believe, not so long. Let me just see. Yeah, not so long. And let's try just to go quickly through it. I believe we can finish with this, and then we can go to your code about tic-tac-toe. Let's see keyword reference. So address space, we do OK, and the combination for address space. Align can be used to specify the alignment of a pointer. It can also be used after a variable or function declaration to specify the alignment of pointers to the variable or function. Okay. Allow 0. Allow 0. The pointer attribute allow 0 allows a pointer to have address 0. Okay. And the Boolean operator. Any frame can be used as a type for variables which hold pointers to function frames. Okay, any type function parameters can be declared with any type in place of the type. The type will be inferred where the function is called. ASM, we can guess. Assembly begins an inline assembly expression. This allows for directly controlling the machine code generated on compilation. Async can be used before a function call to get a pointer to the function's frame when it suspends. Await, yeah, async await always together. Async await can be used to suspend the current function until the frame provided after the await completes. Await copies the value returned from the target function frame to the caller. Okay, break can be used with the block label to return a value from the block. It can also be used to exit a loop before iteration completes naturally. Call conv can be used to specify the calling convention in a function type. This is something new. I haven't seen it, or I don't remember seeing it. Catch can be used to evaluate the expression if the expression before it evaluates to an error. Yeah, this is cool how they use this catch in the expression. So it's not like try catch or try except in other languages where you need a code block. Here they use it on expression. This is also very interesting. The expression after the catch can optionally capture the error value. Let me see what you guys wrote. Robert says, actually never encountered that. My ID uses spaces instead of them. About the tabs, right? And Andre says, then this is only a problem when copying something into comments, but is also but it's easy to fix with search replace. Yeah, Async and now Robert says async and await are a bit dead now, will be replaced by IO interface in the future. Aha. User space, stack full, async in future, possible stackless too. Interesting, interesting. Then comp time before a declaration can be used to label variables or function parameters as known at compile time. It can also be used to guarantee an expression is run at compile time. Okay. See also comp time. Okay. Const is declaring a variable that cannot be modified. It's weird how they say it declares a variable that cannot be modified. Okay, used as a pointer attribute. It denotes the value referenced by the pointer cannot be modified. Okay. Yeah, okay, because it makes sense because it's what it referenced to is constant. Continue can be used in a loop to jump back to at the beginning of the loop. Defer will execute an expression when control flows leave the current block. Aha, so it's not only for reserved for memory management, but in that case it makes the most sense. Let's see what Robert says. Zig is strongly opinionated that there should not be colored functions. Else can be used to provide an alternate branch for if, switch, while, and for expressions. If used after an if expression, the else branch will be executed if the test value returns false, null, or an error. Okay. So not only false, but false, null, or error. If used with a switch expression, the else branch will be executed if the test value matches no other cases. Okay. If used after loop expression, the else branch will be executed if the loop finishes without breaking. That's logical. Then the enum defines an enum type. Error defer will execute an expression when control flow leaves the current block if the function returns an error. The error defer expression can capture the unwrapped value. Then we have the error, defines an error type. Then we have export, makes a function or variable externally visible in the generated object file. Exported functions default to the C calling convention. Extern can be used to declare a function or variable that will be resolved at link time, when linking statically, or at runtime, when linking dynamically. So this is like I always miss the commas. So it will be resolved at link time when linking statically, or at runtime when linking dynamically. Okay. So then function fn declares a function for expression can be used to iterate over the elements of a slice array or tuple. So slice array or tuple. And it's interesting because tuple is anonymous struct, but you cannot use a for on a struct that is not anonymous. That's interesting. If expression can test Boolean expressions, optional values, or error unions. Yeah, so these two things are specific. For optional values or error unions, the if expression can capture the unwrapped value. Inline can be used to label a loop expression such that it will be unrolled at compile time. It can also be used to force a function to be inlined at all call sites. A link section keyword can be used to specify what section the function or global variable will be put into. Okay, so for example, .text. Okay. Then no alias. Okay, to do no inline. This allows functions to be function to be inlined in all call sites. Then no suspend can be used in front of a block, statement, or expression to mark a scope where no suspension points are reached, in particular, inside a no suspend scope, using the, so in particular now they are actually giving the example, so using the suspend keyword results in compile error, using a wait on a function frame which hasn't completed yet results in safety checked illegal behavior. Calling an async function may result in safety checked illegal behavior because it's equivalent to await async some async function, okay, which contains an await. Code inside a no suspend scope does not cause the enclosing function to become an async function. Opaque defines an opaque type or the boolean or else can be used to evaluate an expression if the expression before it evaluates to null. Packed before struct definition changes the struct's in-memory layout to the guaranteed packed layout. So yeah, we covered this as well. Pub in front of a top-level declaration makes the declaration available to reference from different file than the one it is declared in. Resume will continue execution of a function frame after the point the function was suspended. Or return exits a function with value. Struct defines a struct. Suspend will cause control flow to return to the call site or resumer of the function. Suspend can also be used before a block within a function to allow the function access to its frame before control flow returns to the call site. That's interesting. Switch expression can be used to test values of a common type. Switch cases can capture field values of a tagged union. Tests can be used to denote a top-level block of code used to make sure behavior meets expectations. Thread local can be used to specify a variable that is thread local. Try evaluates an error union expression. If it is an error, it returns from the current function with the same error. Otherwise, the expression results in the unwrapped value. Yeah, this is also very cool. I remember this. Union defines a union. Unreachable can be used to assert that control flow will never happen upon a particular location depending on the build mode. Unreachable may emit a panic. Emits a panic in debug and release safe mode or when using Zig test. Does not emit a panic, release fast and release small mode. Using namespace is a top-level declaration that imports all the public declarations of the operand, which must be a struct, union, or enum into the current scope. We have 3 more, and we're done. Let me see what you guys wrote. Otto says, at least it's different. Andrei says, defer is generally for any kind of resources. Yeah, so this is like the comment to what I said when I mentioned it's not only... it looks that it's not only for memory management. Then Robert says, I'm not proud of that, but I have used defer to do some disturbing stuff with printing to console. Then Dev says, tuple is also mutable, right? Then Andre responded, tuples are mutable. Yeah, so in Python, the tuples are immutable, for example. So yeah, it's crazy how they call the different things with the same name in different languages. Robert says Zig tuples are interesting. They are literally just not named structs. Generally, they are used as immutable, but I bet you could make it a variable. Andrei says tuples additionally have interesting property where two tuple. Yeah, by the way, I think Americans call tuples tuple, I believe, and British English in British English they say tuple. So sometimes if I just like switch from one to the other, it will happen. Yeah. They additionally have interesting property where two tuple with the same types are considered same type, where struct with the same fields or same type won't be the same. This is interesting. Yeah. And then Robert says to specify the layout of them is static, like number of fields, field types, but you can instantiate them and mutate them. Yeah, in Python, for example, you cannot change what's inside at all. So you literally have to convert it. If you want to change a tuple, you cannot, but you can, let's say, convert it to a list, then change it, and then create a tuple out of that list, which is now a different one. So it's not the same, but it's kind of like you're kind of changing it, but you're not. Okay, let's see these last three keywords. Var declares a variable that may be modified. Volatile can be used to denote loads or stores of a pointer. Have side effects. Wait, I have to read this one more time. Can be used to denote loads or stores. When it loads or it stores. Okay, of a pointer have side effects. It can also modify an inline assembly expression to denote it has side effects. Then a while, the last one. Expression can be used to repeatedly test a boolean, optional, or error union expression, and cease looping when that expression evaluates to false, null, or an error. So like if same things. Yeah, so we went through all of these. So let me just take a look what I can do tomorrow before I start this other part that is about Robert's version of tic-tac-toe. So give me just a second to illegal behavior. So maybe this is the topic for tomorrow, because there aren't many things left. I think I will do this one tomorrow, because it is important. And it's a huge one, but I will try to finish it. Then memory I did today, this thing I did yesterday, these things, Zigbee system I will leave for the end. Yeah, we're literally almost out of topics from the documentation, so that's cool. So then I guess I will cover also the WebAssembly. So I wanted to save it for the end if I go through the most general use cases of Zig. But then I think definitely I will have time for WebAssembly. Let me see what you guys wrote. Andre says this is because structs are identified by their name, okay, or generator name in case of anonymous structs. Where tuples are identified by literally listings all the types inside of them. Yeah, it makes sense. Okay, so I think I will stop here for this regular part of the stream. So I think it's better to stop this stream and create another one for the tic-tac-toe, so that we have them separate, that people can easily find the video one or the other if they want to, so that they don't have to search in this video where the tic-tac-toe was discussed. So I can, how do you pass a tuple then? What do you mean? You use the tuples all the time. So this is a tuple. So where you print here, you pass them all the time. So here, this is a tuple here. It's usually you have something here. So you will have something like X and Y, for example. You can define them here. And then you will say something like var X equals 1, var Y equals 3. So this is now literally your tuple here, anonymous struct. So they are the same. They call them sometimes anonymous structs in the docs, at least. So they call them sometimes anonymous structs. Sometimes they are calling them tuples. And then, of course, for this to work, you have to have something like this inside to interpolate these two things from the tuple. But this is how you can pass, for example, into this print function. You can pass it normally like anything else, any other type. So you write a literal. Okay. Yeah, so I think I will end it here. And I will start literally like I will just need maybe 10-15 minutes just to prepare in this OBS studio to prepare the stream for the tic-tac-toe, the Robert's improvement of. Let me see what Robert says before we go. When talking in the function, you often take them as tuple any type. Thanks for explaining that, Robert. Yeah, I'm at the level now that I remember using some things, but I don't know how officially they are naming things and how flexible these things are. So maybe I know just like one flavor of using something, and there are like 5 different ways of doing, and there is much more under the hood. I just like when you asked the question, Dev, I just remembered this most common way I use them. So that's why I explained it in this way. But of course, Robert knows much more. Can we use different vars in a single tuple? Let's see what Robert says. Just to specify, the goal was not to make the best tic-tac-toe, even though is an improvement in functionality. The goal was to show some language stuff you can do here, there. Yeah. So I remember that you said that. Yeah, that's more important. So of course, the tic-tac-toe, it's just a tool for learning Zig, and the point is what you just said, that you used other things that are interesting to see how they work and how they could be applied in this tech-toe, not necessarily like you said to improve it, but just to do it in a way that's interesting to demonstrate some topic. Native setup 1. Yeah, native 1. Yeah, this is the most common question. I cannot run away from it much longer because I'm out of topics. I will have to do this build parts of docs, and I have to have something to build and somewhere to build. Definitely the day is coming. Cannot escape. LSP would be nice, especially the type in thing. Yeah. So I forgot who recommended that I install the LSP from a specific website. I forgot which one. I have it open somewhere in some tabs. But yeah, I've seen that it's like they said, if you install Visual Studio Code, then you get everything out of the box. You don't have to, like if you install the plugin in Visual Studio Code, you don't have to do anything specific. But I also want to do it the manual way, and for example, run it's in CLion on JetBrains, right? So not only in the Visual Studio Code, which is basically like probably 3 clicks or something. Don't be afraid, child. Yes, master. Okay, guys, so I will stop here this part of the stream. Let me just first see what Robert says. Zig extension should handle all in the happy path. Yeah. So, yeah, it's so weird sometimes. So I mentioned before that I was a part of the team. Let me go here in the outro at least so that we don't get distracted by the docs. So I mentioned before that I was a part of the team that consisted like of 200 developers that worked on a specific project that is a huge one. And it was built for 15 years, I think, something like that. I forgot. And when they switched me to this project, of course, because it's so huge, we had to have some training. So there was this guy who actually architected the thing, and his colleague, they came from Italy because it was Italian company to teach us, and we spent like a week just setting up the system. It was Java, so we were setting up the Java and all these dependencies that they have and everything, and we were following, I forgot, like 3 or 4 of us, I don't remember, in the first group. So the guy was sitting next to us, and we all followed the same tutorial step by step. I mean, not even the tutorial, the guy was explaining in person, and we all did like little babies, like all the steps together. And all the colleagues, when we reached some point, everything was fine for them. Only my machine completely crashed and it couldn't run. And then the guy thought that something I didn't just like follow up something that he did. Then I believe he reinstalled everything on my machine, and he tried to do the same, and it crashed again. So it was something like hardware, little thingy that made everything crash only on my machine. So he couldn't install it also on my machine. And then I forgot what we did at the end. So there was it was at the end fixed in one way or the other. I forgot if I changed the computer or something. I forgot, but this is what happened. So all of us following the same tutorial. I mean, not even the tutorial. The guy was in person explaining things, and there is some piece of hardware that simply rebels, and that's it. Let me see what you guys say. Otto says, have you tried Ziegling's exercises? No, I was recommended here to do the Zieglings. I think I will do them next after these 30 days of basic Zig challenge. I think the next stream live, I will stream that. Let me see what Andre says. Italian man teaching. Yeah, it was Italian company. So they are dominating the Italian market. So they cover this software that I was working on is covering, I think 70, if I remember correctly, 70 or 80% of the health industry in Italy. So it's a huge company and they have the monopoly. And I think they're sold now. They're not Italian anymore. I think some US company bought them. So when I was working, it was 12,000 people. Most of them were developers, but I forgot exactly how many developers and how many administrative workers and so on. But 12,000 was the number, and they were huge. So in Brazil, for example, the company had, in Brazil, you have 5 mobile operators. At that time, there are 5. Maybe it's different today. And they had 4 of them as clients. So a huge company. I haven't touched this part, the mobile part. I just worked on different projects. So one of these projects was this health project. And I did my first project was for the Ministry of Justice of Italy, their web portal, something. I mostly did, so it was Java framework, so I did backend all the time, but Java part was easy, let's say. So the most of the bugs that I was solving were on the front end, so JavaScript and CSS, actually. So I remember my first task was to fix some issues that were making the CSS because they copy pasted from some. I mean, someone designed for them. They're not. They didn't copy paste from like some third party. So someone was paid to make a UI design in CSS, but at some point in time they changed the structure of everything, and then simply this, of course, didn't work anymore, CSS. And it was like, I don't know how many CSS classes, and I literally, it was so large and so huge that I literally like did the binary selection. So I comment out the half of the code, then see if there is still a bug, then I comment out the other half, and so like binary approach. And the problem was that it was not only like one class, there was like, of course, cascading. They were cascading, and I had to research deeper in different ways, but this was like my first approach because it's so huge, like CSS base. Yeah, classic approach. Yeah. Okay, guys, so see you in maybe 15 minutes. I will just wrap this one here, and I will create a new stream for Tic-Tac-Toe, the Roberts version, and then I will start as soon as possible. So literally, I'm not going to take a break. I will just create the stream, and that's pretty much it. I believe in 15 minutes I will be able to test everything. If everything is fine, no surprises, and then I will start the stream again. Let me just see one more time what Robert says, the last comment for now. Robert says, my favorite thing from OP is C++ virtual constructor. I'm still not 100% sure why it exists. Yeah, those are some mysteries of life. See ya, Dev, yeah. Andre says, just fixed, but with virtual constructors in the code base bug. Okay, thank you guys. See you in literally in 15 minutes. I will be back. I'll be back. Bye-bye.